Welcome. This question says a material has a resistivity of 4 ohm meters at 20 degrees C. The same material has a resistivity of 9 ohm meters at 30 degrees C. What is the coefficient of resistivity of the material? Basically what you find is that if you look at a resistivity versus temperature relationship for many materials over a certain range of temperatures, then you find that it follows a kind of linear relationship. If you increase the temperature, you increase the resistivity, and you can pictorially justify that by saying that as the atoms vibrate more, they cover a larger area in the wire that the charges of the current have to flow past. If they're vibrating more, then it's as if they're bigger. We talk about cross-sectional effect. So conceptually that makes sense. And the governing relationship is that the new resistivity is equal to the old resistivity, or a standard resistivity. 1 plus, it's going to be the coefficient of resistivity, and then the temperature change, T minus T0. Where in this nomenclature, the rho and the T are to do with the new state of the material, and the rho naught and the T naught are to do with the old state or the standard state of the material. So what we can say, well, what do we know? And what the question tells us is that the new resistivity is what I want, and the original resistivity, oh, I'm sorry, that's not true. Let me back up. The new resistivity I know, and the new resistivity is 9 and 9 with 30. So the new resistivity is 9 ohm meters, and the new temperature is equal to 30 degrees C, and if you like, that's a point on here. And then the old resistivity, or the standard resistivity, is 4 ohm meters, and that corresponds to a temperature there, and that would be somewhere like that. And so I want to find out this coefficient. So if I rearrange, I say, well, alpha is equal to, it's going to be resistivity minus the standard resistivity, taking that to the other side, and then we say divided by resistivity times temperature minus the standard temperature. That resistivity there multiplies throughout and then is put underneath. So if I substitute numbers in, let's get some numbers here. So if I look at this, I find that, oh yeah, I have 9 minus 4 over, and then that is going to be 4 times, now my temperatures, 30 minus 20. So I say, well, my alpha is equal to 5 over 40, which is like 1 over 8, which is 0.125. And without looking at the answer key, because in my class you don't get multiple choice, it's all free open answers. We've got to figure out what the units are. And resistivity is ohm meter. So we have a difference makes no difference, it's just the same units. Ohm meter divided by ohm meter goes away. So I have 1 over degrees C in this case, because my temperatures are in degrees C. So this will be degrees C to the minus 1. So there I have it. It's a temperature. So learn the equation, and then watch out for the units, and rearrange. Now remember, I could give you the alpha and ask you what the old resistivity was, or the new resistivity, or the old temperature or new temperature. The key fact is, with one equation there can only be one unknown, so one way or another I have to give you everything else. So there we have it.